So this right here is two graphs. The graph shows a square root equation f and a cubic equation g. So which one's the square root? Well, can't you tell the red is the square root?
Yeah.
And this is the cubic. So let's label that to start with. That's going to be kind of important. So the red one is your f of x. And the blue one, or this right here, is your cubic. Just so we can reference which is which. All right? So that's the starting point. Now, what is the solution to the equation g of x minus f of x equals 0? The solution is, what is the x value? For which the x value minus the g value minus the f value equals 0. Well, to subtract two numbers and get a 0, don't both these have to be the same? So aren't we really looking where g and f are equal? Or, if you think about it this way, watch this. Can't we just add f over? And aren't we finding where g of x equals f of x? But isn't that what it means? If I plug in number 5 in here, doesn't this also have to be 5? If I plug in 8, doesn't it have to be 8 to equal 0? Isn't it saying, basically, we want to know where the two functions are equal? And can you look at the graph to figure that out?
Yeah.
Aren't they equal right there? That is not 6, it's at 3. So my answer is, when are they equal? Is when x equals 3. Because at 3, they're both 6, so it's 6 minus 6 is 0. So, again, x equals 3 because at 3, they intersect right there, right here at 6 high, but they intersect at x equals 3. Now the next one, on what interval, integer interval, might there be a solution to the equation blank? Well, to make a number plus a number equals 0, don't these have to be opposites of each other? If this is 3, it doesn't have to be negative 3. This is 8, it doesn't have to be negative 8. Or you could think of it this way. Could I minus g of x over? And aren't we really looking for when f of x equals the opposite of g of x, which that's what we just said. If this is 8, this has to be negative 8. They have to be opposites of each other. So look at the graph. Where are the values opposite of each other? For instance, right here at 1, this is a positive 4 point something, but this is a negative 1. They're opposites of each other, but not opposite equal values. Here at 2, 0 and 5.3. They're not opposites of each other. Okay, look at 0. I have a 4 and a negative 2. Oh, they're getting closer to being opposites. It's a positive 4 and a negative 2. Okay, wouldn't somewhere in this interval right here, think about this. Just very carefully think about this. In this interval right here, can't you imagine right in here, won't there be a spot where the value on this is equal to the value on this? They're just opposites of each other. Somewhere in here, we can't see it exactly, but somewhere in that interval, there'll be a spot where you probably get like a positive 3 point something and a negative 3 point something, and there'll be something in there where they're one's positive, one negative, equal value, equal kind of number, but opposites. So it'd be somewhere in that interval, and that interval would be called negative 1 to 0. Or you could say from negative 1 less than or equal to x to less than or equal to 0. Either of those would be reasonable integer intervals. Those are integers, and it's an interval. So now, for this last one, why is it not possible for the ordered pair 8, 7 to be a solution for f of x? So isn't the red graph f of x? If I did 8, 7, wouldn't 8, 7 be, somewhere, let me look at this. If this is 7 high and 8, wouldn't 8 be over here somewhere and 7 be right here, somewhere in here? Isn't it saying there's a dot somewhere like right here? Why is that not reasonable? Well, it's a square root graph. Isn't it going to keep going higher and higher than that? It's 7 right here. How's it going to drop back down to another 7? If it's 7 there, how would you get 7 out again if it keeps going up? So 8, 7 doesn't make any sense. Because you already have an output of 7, you can't get another output of 7 with the square root graph later on. So you have to explain that. And so how would we explain that? Well, I kind of just said it. Basically, at x equals, 5, don't you already have an output of 7? At x equals 5, actually I'm going to rewrite that. Instead of x equals 5, let me restate this. At f of x, at f of 5, doesn't it equal 7 already? So how could f of 8 equal 7? If f of x is a square root function. Because how square root functions operate, it would not be possible to have an output of 7 twice. Because at 5 you already have 7, so at 8 you can't have 7. That's what 8, 7 means. It means f of 8 equals 7.